Good afternoon, coders, and welcome back to the Northern Ireland Raspberry Jam Live. This month is the NI Raspberry Jam NI Science Festival edition because this month, for this week, is the NI Science Festival event in Northern Ireland. We have two workshops lined up this month, and for today, we have one that will run on your browser and one that will run in space. Once again, we'd like to thank Nitech Solutions Limited for letting us use their building, and more specifically, this really cool workshop space to host this month's jam. Firstly, we're going on a trip to the ISS that needs your help. You will learn about the Astro Pi, which allows your code to run in space, and you can collect little bits of data if you're in one of the other competitions, which we'll talk about later. After that, we'll have a short break so you can stretch your legs and get some water, followed up by a short video from Isa about the new Astro Pis in space. And lastly, we have another workshop working with MakeCode Arcade to design your own game. All you'll need for the workshops are a laptop and a web browser that can run on them. Something like Chrome or Firefox will do perfect. If you have any issues at all or any questions for myself or the team, feel free to pop them into the live chat and a member of our team will help you out. Specifically Jack. He's on site, thankfully, and very helpfully helping us. For now though, let's get started with Astro Pi. So, to give you an idea, the Astro Pi is a program that was launched quite a few years ago. There was even an event local to here in Belfast, well, this isn't Belfast, but in Northern Ireland, in Belfast, where, just to clarify, a rocket was not launched from Belfast, but there was a kind of a gathering for students and such to celebrate the fact that Tim Peake, one of the astronauts in the European Space Agency, was going up to the International Space Station with two Raspberry Pis. These Raspberry Pis were very special in a way. They were little computers, and on them, they had enough hardware that you could run and do tests in space with the computers completely autonomously, and they would just collect data and you could do little projects on them. And the European Space Agency thought they would open it up. And now, for the past, I think, 5 years, they've allowed people like yourself to go online and to submit code. And there are a couple of caveats just that you need to be aware of, but we'll cover them shortly. But you will be able to run code that you've written from your browser. It will check it's okay, so you're not trying to hack into the International Space Station, and it will allow you to run your code on the space station. Now, more specifically, the project is called Mission Zero. So to get started, we're going to go to Google. So if you open up a new tab, and what we're going to type in, and I will do it on my screen too, so you can see exactly what I'm doing. I'm going to go to Google. So on Google, I'm just going to type in Mission Zero code. And then immediately it'll pop up with a couple of options for your search. We don't want to click the first one, but if you are interested, that'll explain some of the things in more detail. However, we have a video coming up soon to tell you exactly some of the new details from the new Pis that are currently in space. But the second one, this one with Trinket is a little program that allows you to code on your browser. Specifically this link for trinket.io Mission Zero. If you click on that, it'll bring you to this screen. Now I already have the screen here, so I'll just use this one here. And it'll give you kind of a bit of a synopsis, so a bit of a small crunch of detail on what it is. To get started though as well, we have a worksheet for you, just to have a little bit of guidance. So a member of our team, Jack, will post the link to a Google Drive document with the code, all the kind of code that you'll need for this workshop. It has rules on the bottom, but I think they have changed since the last time we have changed this worksheet. The idea is that anyone can do it. So parents, feel free to do it. Kids, obviously do it. It's very fun, and you can just tell people you've done it. Anyone age 19 or under can submit their code up to space. Anyone over 19, including myself, because I'm very old, will not be able to submit it to space, sadly. But you'll get a certificate saying that you've actually done it. But for those who are 19 or under, when your code runs on the space station, you will get an actual certificate sent to your email, and it will say the exact location, the exact time, well, location in respect to where it is coming, looking down on Earth, the time it was run, and the team that you were with. So you can do it by yourself, but if you have a family, we'd love to see teams put through some of their own little kind of code snippets. So that is thankfully hopefully everyone could do it. But for those who are ready to go, I'm going to give a brief explanation of what code's already here, just to kind of get you up to scratch, and then we'll follow off the code that is on the worksheet. And if you can't get the worksheet, no problem. We will be showing everything on screen, so you can copy it down if you want to write it and you want to change it. I'll tell you what can be done and how you can kind of make it your own. So, start off, we will view in Trinket. We have this window on the left-hand side, which is where our code will be put, and we will run the code that is in this little box. You'll see the very obvious run button. If you want to give that a click, what you'll see is it will do nothing, which is what it's meant to do. We haven't told the Pi to do anything yet, so not to worry, it's not broken. Thankfully, it's not broken, the real one either. But on the right-hand side, you'll see there's this box. I say box, very, it's a very expensive box, let's just say that. It's got quite a few little features on it, which I'll not go into details for because there's a video that'll explain everything, and it will know far better than I will, because it's coming from a real astronaut, and I am not a real astronaut, because I don't like heights. And you've got little kind of different sensors that you can kind of modify, so your temperature, your pressure, and your humidity. Now, to give an explanation of why all this is there, is because you have a Raspberry Pi below this and a sense hat on top. The sense hat has lots of little kind of board, like little functional features actually. Little chips on the board which will allow you to have different kind of sensors. There's something called an IMU as well, an inertial measurement unit. So if you shake your sense hat, it'll measure it, so it will. But the main thing we're going to work on is the temperature and the LED display, because the requirements, if you scroll down, will say your program needs to read humidity, not temperature, read the humidity sensor, which we will be doing, and use the LED matrix or the display on it. So that's the one up here. You'll see it working in action very shortly. And also, no errors. We can't submit any errors. And I think as well, it has to be less than 30 seconds. Qualified submissions will run on the International Space Station as long as less or equal to 30 seconds. Perfect. So, for the code, the initial kind of setup, this is Python. This language is quite nicely kind of introductory language for those who are interested in getting started. Essentially, what you're doing is you're bringing in everything for Python, the program, the language, to understand what you're going to be working with. Because if you import like everything ever on Earth, it will not really, it'll not really make your program any easier to work with, because people can have their own versions of SenseHats, or if you've changed your code, and various other reasons. A little bit hard to explain just on camera, but we need this to set up our SenseHat. So the next line will show us that we are using that SenseHat called a library, and we're saying sense, which is a new object from this library, as a new SenseHat. So sense is what we're going to use, and we're going to reference to actually talk to this virtual one, and then we'll talk to the real one up in space. So the first line that we have written for us, I'll separate this out just to give an idea. On line, for use it'll be line 3, but line 5, sense.set rotation basically rotates this LED matrix on the right hand side by 270 degrees. The reason is, if we didn't do it, actually I can show you right now. Actually no, let's keep it there. I'll show you later why it's useful, but it's used to rotate the screen. So yes, now those 3 basic ones are covered. They're required though. Maybe not the set rotation, but the first 2 are definitely required. Nothing else will work without them. Anyway, the first thing we're going to do is get the humidity, because that's a requirement. So if we type in how we're going to get this, so we're going to say we need to get the humidity. To get the humidity, we use something called sense, which is our object for the SenseHat, .get underscore humidity. H-U-M-I-D-I-T-Y. I checked my own spelling. Now, this in as itself will qualify. That'll say, yep, you read from the humidity sensor. That's perfect, dead on. And what we're doing is basically saying, telling SenseHat, go off to your sensors and pick up that value. We want to pick up the humidity, current humidity that's being measured from the board. And so Python, no problem, it can do it. But this isn't really useful. We've just read it, and if we read further below, we'll see that yep, tick the box. You can submit it if you use the LED matrix with this line, all good. But let's change it up a little bit. So we can use something called a variable. Now, in programs, variables are very useful. Think of them as kind of little stores of information that you can assign specific values to. So you've got many different types of things to store, or data types. Briefly, kind of the ones you'll mainly work with are either of a numeric form, like a number, or in some form of a string, like a string of characters. So my name, Sam, would be a string of 3 characters. It would be SAM. And so these variables can hold information like that. Now, this sense.getHumidity returns a numeric value, which has like a number after numbers after the decimal place, or a floating point number. Now, we want to take that, we want to capture that value into a variable. Very easily done. I'll show you in a moment. And we can actually print that out, so we can show it on the display. Maybe if the the astronauts are going through the space station and they're just zooming by the Pi and they see, oh, it is 38% humidity. Well, as would be said on this emulator right here. So to actually use a variable, though, very simply, I'm going to call mine humidity. So the name of it, humidity. And then to assign the value from this, or the output of this, to a humidity, we'll use an equal sign. So we'll say humidity is equal to sense.getHumidity. And that'll just say, whatever the value of this is, store it in humidity, and we'll use it later. It's really easy to use and really, 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 really fun, where you can do with variables. So now that we've stored that, great. What are we going to do with it? Well, we can print it out, easily enough. On display, we have lots of little different options. We can actually tinker with things like the scroll speed, so we can like make it zoom by or go really slowly. And things like the color can be changed. So you've got 2 colors, which is the front text color, and you've got the background color. So the text is overlaid on top of the background, and whenever the text is actually printed, you can kind of color it to your heart's content. There's quite a number. I think there's like 65,000 variations of the color that you can use in this, I think. Don't quote me on that. But we have a couple of examples in the worksheet on the right hand side, and they're called RGB values, but we'll work on that later. The first thing we need to do is get the text printing. So to do that, once again, we're going to use our sense object. So sense being the sense app, we're going to tell it to show underscore message. Now, this is where our data types come back in, and this thing called a string. Now, we've actually seen one of these. We've seen one of these before, where we're gonna pass in a value straight into what's called a function. So a function just has these wee brackets after them. There's a couple of other rules about them, but I'll not go into detail here. And the way that what we're gonna do is we're gonna pass a string, or our message, which will be our string, which will be a string, into show message. And to do that, we're gonna say show message, and we're gonna have round brackets, and inside of them, we're gonna put quotation marks. And anything with quotes around it basically says it is a string. So you can see the colors change there. It's gone a little bit of a golden brown. Make sure it changes color, because then that means it has worked, and now you're typing a string. So I'm going to say, hello world. And then that will say to this function, show message, to print or to show this message, hello world, on the still display. And now, finally, after tinkering with this for so long, we can actually hit above this, the run button, and it will actually do something. And you'll see hello world with an exclamation mark at the end. And that's it. So very straightforward, very, very simple, but that now allows us to very straightforwardly print information to the screen. And regardless of what you want to print, you can print loads of stuff. You can print something very long, as long as it's less than 30 seconds. And if you really want to, you could print off, like, I don't know, a URL or something like that. They're obviously not going to type it in, but at blazing speed to get like a really long message or something like that in. But we'll show you how to do that shortly. Now, for our next part, what I'm going to do is we're going to use something called an F string. Now, this isn't shown in the worksheet, so this is something very, like, a little bit different. But I'll keep an example on the stream for you to see at all times, so you have a bit of a reference and so that you don't lose it. Now, because the worksheet's a bit older, it has an older way of doing the converting the number to a string, because the number and the string are two different things. You can't just mash them together and expect them to work. We need to tell Python, the programming language, what we want to do with our humidity. So we need to try and join or concatenate, it's a very long word, to join the number and the string together and then have them display through the show message. So we can just, very straightforward, if I remove my message here, so we've got hello world, and say, instead of that, we say humidity, H-U-M-I-D-I-T-Y, is, and then put a space. Now, at this moment in time, we can't just drop it in. What we need to do is we need to tell Python this is an F string. Now, this also might, I think this supports Python 3. We shall find out. There's only a specific version that this works on. It should be the latest version. So we're going to check and see if this works. If it doesn't, we'll have a backup one, don't worry. Very easily, we're going to put an F in front of this, and I don't think it works because it's not highlighting. So already we have to go back to the original one. So the worksheet is the one to use. What we're going to do is we're going to have, instead of a message, we're going to use something called a cast. A cast is basically converting one type of variable to another. So we're going to convert number to string. Very simply, str is kind of a shortened version of string. And in round brackets, once again. Now, actually, if you look very closely, that's got like a little purple kind of plum color. And that's kind of said, oh, Python has recognized what this is. Just like import, it recognizes what that is. From the equal signs and even the numbers, it recognizes what it is. Just like the strings as well, actually. We want to say our number, or humidity, which is a number. We want it to go as we want to turn it into a string, and then it'll show it as a message on the display. So we will type in our variable name from line 7 here, humidity, H-U-M-I-D-I-T-Y, humidity. Perfect. Now, you may be thinking, oh, actually, no, I should probably run this, actually test if it works. It's a very good idea. Test what you've written just to make sure it works. Because then later on, if you haven't tested it, you're thinking, what could have possibly gone wrong? Many things can go wrong. So, always good to test. So let's run. Oops, 36 point. Okay, I can barely read that, but we'll fix that. 3, it's, oh, right, okay, sorry, no. And, yep, that actually worked. Perfect. And we can actually adjust, so in our little emulator on the right hand side, we can adjust our little variable here for the humidity. So let's say we want it to be 100%, we just fire it up to 100%. We hit run, and 99.46287355505, and that's it. So just in case you want to know the humidity of this little box in the emulator. So nicely done. Simply done. That's printing humidity. Now, you may want to say, oh, just for niceties to kind of show what's happening, you can do sense.show underscore message. And in here, put in humidity is just like we wanted to do before, where I wanted to kind of put the string and the number together, but sadly, it is a bit more complicated than that. So for simplicity, we will have them as two separate messages, and they'll just flow out one after another very easily. Now, that's all cool, and printing humidity is okay, and we've checked everything, so I think everything actually does run. So if I hit run now, because whenever you change your code, it needs to be reran to verify everything. If we hit run, we're gonna wait for this message to complete. Exciting, I know. And just like that. Okay, so our program is finished. Let's check if it actually qualifies. So if I scroll down, I've got 3 ticks and I've got 16 seconds, which is in fact under 30 seconds. So at that point, you can submit your code. But what we're going to do is, for those who are wanting to tinker about a little bit more, we're going to give about maybe 5 minutes, just kind of tinker around, and then I'll give you the super secret code to submit the your code to space. Now, what I want to do as well is I'm going to do a little bit of coloring. So I'm going to color the background primarily. And what I can do is basically say, in my show message, so humidity is a white, the text is white and the background is black. So let's say I want to make the text green. I will put a little comma between this quote and this bracket. So right there. And I'll say, okay. Since show message will basically recognize this as saying, oh, here's your message. And then anything after the comma will say, oh, right, what do you want to do with it? Do you want to modify the color? Do you want to, well, it's the back color, the text color, and the scroll speed. So I think I'll do back color, or no, front color for the text. So I'll do space. So it goes comma, space. We'll do text underscore COLOR equal to, and in square brackets, which are kind of like the jaggedy ones of the round brackets, that's not a technical term, but the square brackets will then have inside of it 3 values. So we're going to have 3 numbers, and that will be like the red, green, blue value for our color. And the way that this works is you have, think of it like 3 lights. You have 3 bulbs, and you have a red, a green, and a blue bulb, and you can vary how bright those bulbs are from 0 to 255. And very simply put, though, if you combine those colors then, so looking at them straight on, obviously you can see, if you have 3 bulbs, you're like, oh right, the red has gone very dim, oh the red's gone very bright. But if you combine those colors together, what you get is a lot of variable colors that you can then pick from. So as long as you maybe set more red, less blue, and a bit of green, you can get colors from all over the spectrum. So for example, to put all of them bright, so if you put red, green, and blue all bright, you get white. If you put them all to 0, basically like very, very dim or off, they go to black. And then colors like on the worksheet, colors like red, if you just want red, you just want the red bulb on, very simply put. So you have red and then no other ones. And then for something like orange, you have red on 100%. And then to mix orange, you need a bit of red and a bit of green. So whenever you get red, you want to add maybe half of the green. So half of 255 is about 127. So 255, 127, and then we don't want any blue, so 0. So 255, 127, and 0. And that allows us to put it all together. So I'm going to say, maybe I want my, what color do I want this to be? I'm going to put it to be blue. Actually, no, I'll do like a purple color. So I'll do 255, 0, 255. And I've got that color from the spreadsheet, or the worksheet, sorry. And that'll allow me to use blue specifically, or purple, sorry, specifically. So if I run this, you'll notice that my humidity is text will be purple, there, or a bit of a magenta. And then it'll go straight to white on black, they are, because that is not the message that we modified. We only modified this show message. So if you want to modify this one, very simple, you just do the exact same thing. And there's a great tool for that called copy and paste. So we're going to copy this. So if you want to drag your cursor and highlight, and then you want to copy this, so I'm going to press my copy, and then I'm going to paste it, and then suddenly I'm going to hit run. I'm going to hit run. I'll go purple. And then the humidity will also go purple. And that all comes together. So to give you an idea, what I'll have on screen as well for you is a preview of the worksheet. So just to have on the side. So for those who can't bring it up on their own device, will have the RGB colors there. And I can bring that up for yourself. And I'll put in, there should be a couple of other little details I can pop in for you as well. But at this point, I'm pretty happy with that. I like that code. But for now, I'm going to give you about 5 minutes to kind of tinker around yourselves, put in whatever messages you want, put in whatever colors for the text and background. So back color is actually, or background color is actually back underscore color. And then that allows you to basically say the background color is, well, I wouldn't recommend purple, as you'll see in a moment, so I need to run my code again. This is going to be very exciting. So it's going to go bright purple very, very second. They are. So, and now it's going like, well, I actually read that, so that's quite useful. And then it will go back. Or not. Oh no. Wait, so if I run this again, I'm pretty sure this resets everything. Boop. Yes, okay, just double checking. Make sure it's not purple all the time. So that's, in short, the code that you can write to go to space, and mine is definitely not 1 second. I just stopped it too early. So what I'll do is I'll bring up this worksheet. Oop, I'll zoom into this just so you have a reference, and then I will pop this to the right hand side with the text. So I'm going to move this down and use this side of the worksheet. Oop. Oh no. This is why I'm doing a computer science degree. So I'm going to make this a little bit smaller. Okay, we will improvise, and what we'll do is we will put the back up, and I will just pull this over. And this thankfully has the correct content, and hopefully you should be able to read that on your screens at home. And I will make sure that doesn't cover my code. Oh, maybe I can't. Time to go back to the main screen, and then make it a little bit smaller. And then bring it back over, see if it scales up. Perfect. So hopefully you should be able to read that at home. And what happens is your RGB values are to this side. So there's a bunch of different colors for you to kind of rummage about with and see what you can get out of it. And then your example codes is here. So for example, the scroll speed one, which I didn't go over, but if you want to, feel free to add it in, is scroll underscore speed 0.5, or well, 0.05 if you want to go. I think that's really, really quick. Yeah, so if you make the scroll speed smaller, the text will scroll quicker. So if you want to potentially spook an astronaut, feel free to. Although I wouldn't recommend spooking them. Perfect. So yes. So I'll give you 5 minutes to run around with that, and then I will get my own little one going. I will give it a go. So 5 minutes. See you soon. Well, I'll stay here, but I won't talk very much. I'm gonna end it in about 5 minutes. What's the time on the?
We are currently, it's currently 7 to 4.
Oh,
7 or 7 to 2.
what's the time on the timetable? Sorry.
I gave you an extra 16 minutes still.
16.
I pushed everything back 10 minutes.
Ah, okay. No, I can do that then. I'll explain my code.
Huh?
I'll explain the code that I've got.
So you have until 10 past.
Well, that's perfect actually. Thank you.
All right.
I'm gonna start back, so I'm.
All right. Give me 1 second. I'll plug you back in. 3, 2, 1.
So that has been 5 minutes, and hopefully you've had a bit of time tinkering around, kind of getting your code back up to scratch. And if your teammates have all agreed together and have a final solution, so what I'm going to do though is I'm going to pop in a little bit of code I just did. I'm going to pop in here. It's very similar. So I just took a copy of my existing code and I just popped in a little bit of a different kind of twist to some of the show messages. So if the humidity, sorry, not if the humidity, that's an if statement, but prints off humidity and it's really quick, and then it prints off a text version of the humidity variable, and then that obviously prints very quick as well. The other thing that I also print is this is Sam's code in space. Now you could do loads of different things where if you're a little bit more experienced in Python, or if you want to kind of tinker around, this does stay up all year round. You just can't submit your code, obviously, after the competition, or sorry, the challenge is closed. It's not really a competition. What you can do is you can tinker around even maybe in 2 weeks' time, or even when the actual challenge closes, which I am actually not sure when. But for the most part, if you still want to tinker around with this, even when this is finished as well, you can use different Sense Hat workshops. So if you find a worksheet online that you're actually quite interested in, like making the Sense Hat sparkle, or making just kind of interacting with the temperature sensor and other sensors just to kind of see what you can do with it, this will stay online, and you can get tutorials on Python loads of places. And I think at our physical jams, we do have little kind of points where you can speak to the volunteers and kind of ask questions to say, oh, how does this work? How can I do this? Or if you have any other interesting ideas, we're always happy to hear them. And obviously, as long as the code doesn't break anything else, we're happy to help you code it. So we are. But the actual code, I think that should work. And if I run that, so it says humidity, not too quick, but 0.1 is quite a nice speed. So it is, because it goes across quickly enough that you can actually read it, but not so quickly that it blazes past you, and not so slow that it takes up more than 30 seconds. So that's my humidity, and then this is Sam's code in space. Perfect. And from what I can see, nothing's gone wrong. Oh no. Right, we need to improvise. We'll just do Sam's code is in space. And now sadly we have to rerun this, so 30 seconds we'll have to pass again. But to give you an idea, this competition or challenge is closing on the 18th of March 2022. But in the next step, because it's still open, we will have the option to set up your team. So if you've been working as a team with anybody else, you can kind of put your names together and put them onto a form, which we will show you shortly. Or if you're not as a team, you can submit individually. That's also perfectly fine. So, has successfully run 1 second before. I am happy that worked actually. And sadly, because I am very old, I cannot submit mine in space. So I can't go that far, but I'm going to tell you the super duper secret code, which I'm now going to read out and actually put into the text box so you can take it. And what it'll do is basically, it'll let us know whenever the certificates are ready, and so we can email back to you when they are. But it'll also ask for your email, and I'm pretty sure it emails the certificates to use as well, just so you have a copy whenever it's ready. And if not, feel free to drop us an email. So if I put in the super secret code, which is NI-JAM-super-secret. And you'll see in a moment, it's verified that and found that Andrew, who is actually he is the lead of the jam. He's currently not with us, sadly, but he is remote, teaching away in his teaching places, or schools as they call them here. And that'll basically tell Astro Pi this code was submitted for the jam, and by yourself, you'll have the information, the option to input your information shortly. I'm gonna keep that on for a couple more for about 10-15 more seconds, while I'll explain a couple of other things, and then we will carry on. So if you can't submit your code now, don't worry. This isn't like closing whenever we are finished our workshop. Just have a little note of that, just so you can add it on later. And I think the only other thing to mention is that, well, with the Astro Pi as well, now you can't buy this Astro Pi that's in space for various reasons. Obviously, it's in space and it would cost quite a lot of money. But what you can do is you can buy essentially what it is made up of, which is the Pi, and, well, bare bones would be the Pi, and the Sense Hat. And the Sense Hat plugs on top of the Pi, and you can have as much fun as you want with it, because if you buy one at home, you can actually start tinkering with it, actually using the humidity sensor. So you could pick it up and like breathe on it, and it would be able to react to like maybe the color of the screen goes red when humidity is above 50%, and stays green when it's below 50%. So a lot of tinkering around that you can do. But this virtual one will always be open for use to work with. So if I hit continue to form, and I put in all my information, which will be, you're almost done. If I say my team name is Jam, very, very good, very, very good name. And I say my name is Sam, and my age is sadly 20. And so members must be 19 years old or less to be eligible for flight status. So sadly, I cannot take part in this. So sadly, parents, unless you're suspiciously under 20, you cannot submit submit your code to space. So if a single team member, if I'm pretty sure has, so I go Marco, and they are maybe 17. Team members must be 19 years younger. Yeah, just double checking. So you can do that, and basically each team's information. So if I say mail and then mail again, we can submit. Well, Marco's all good, but I'm not, sadly. You can make an unofficial submission, which basically says, okay, we'll send you the information, and what happens is you just get a little kind of certificate of participation. So I'm not going to submit my code because I feel like I've done this for many years, and I have had many certificates from this, so I've loved it every time, and it's been good fun. But let's see if I think that is most of the submission details that you'll need. I'm not going to hit anything else just to make sure I don't cause any issues on our end, because I don't want like random ones come up and we're trying to reference who is who. But for the most part, that is us finished with this workshop. However, I am going to do one more thing, which is show you a couple more resources for the Sense Hat. You've actually, so once you're submitting that, I'm going to mention this. So if you're having to work on something else, by all means, but I'm going to mention this just so you know. Now, one place that you'll get a lot of resources for the Sense Hat, and specifically the resources you can use with this this kind of emulator or virtual Sense Hat, are going to be primarily available from the Raspberry Pi Foundation or raspberrypi.org, and that has lots and lots of different kind of worksheets that you can work through, and just kind of, well, if you're feeling specifically very, very interested in the Sense Hat, this is probably a great place to check what you're going to want to, or see what's available for it. So I'm going to bring over my tab, and I'm going to put it right here. So simply by just doing a Google search of Sense Hat worksheet, you can see that Rakantha is actually someone I think we know personally, but we're going to skip that first link, and we're going to go to the raspberrypi.org official one, and we're going to click on getting started with Sense Hat. So for those who've never worked with it before, just like that kind of bit of introduction with the getting it to rotate, printing messages and such. It's a very similar kind of idea, but obviously this code doesn't go to space, and it's available all year long. It'll have a walkthrough of what your steps you're going to do, and I'll have a good explanation kind of for you to go at your own pace on what you're going to be doing, and you can just kind of walk yourself through it. Now, there's little bits of information where if you have a physical one, or if you buy a physical one, you can do all this. It's no problem. But for some parts, you won't be able to work. You will not use these steps for the virtual one because this will all be set up for you. So, for example, we don't need this one because we don't need to install the package because it's already set up for us. And this is kind of given an idea of the emulator as well in Trinket. So this is an older version, but that's what the Pi would actually look like without the little kind of shell for the Astro Pi. But we're going through displaying text, and it does kind of exactly the same thing, but it does go through a couple of different specific ones. So variable in Python, which you have done, and a loop. So a loop in Python allows you to loop a section of code repeatedly until a condition is met, or maybe forever. So maybe if you want to print hello world forever on the screen, you can, using something like this. So something as well, like if you were to have a while loop saying while the humidity is greater than 50%, so while humidity is greater than 50, it will print maybe humidity high, and then each time it'll check it, and then it'll make sure once it's below 50, it'll just exit the loop. So that'll have more information on how to do those, as I don't think we can cover that as quickly in this. But one thing we didn't do was displaying images, and images are quite cool in terms of the way that you can actually build them up by just dropping little individual pixel colors. So the pixels on this little display are numbered. So you can say, I want this pixel on this kind of x-axis and this y-axis to be blue, and this one to be green, etc., etc. So over and over again, you can build up an image, and then you can kind of work from there and have, like, I think you can do an array as well and just kind of set a bunch of pixels, different colors. There's a Minecraft one where you can basically have a map on your sensat. I think it is a second image on this. It's a little bit more advanced, and it works with the Pi only because the Pi itself has a Minecraft version. Very old, doesn't have like all the cool stuff that the new one has. But you can go through and you can actually run. I think it shows you here. Yeah, so you have your colors for your different kind of blocks. And is there an image? Oh, this would be very cool if it has an image. I don't think so. But it's quite advanced. Yeah, so there you are. So there's something like this. So there's some water, there's some sand, there's some grass, and the little kind of pixel is where you are. And I think that's wood. I'm not sure. But you can do various things with it. And there's a couple of examples. So yes. Now, I think other than that, that will be us wrapping up for that workshop. And what we'll be doing is we'll be leading into our break. Now, our break will also include a video from the European Space Agency. It wasn't sent to us, but we want to have a bit of a synopsis, or a bit of a small video to explain all the details of the actual Astro Pis in space. That'll be done by an actual astronaut, so very much more qualified than I am. Now, to give you an idea as well, these certificates won't be back for a couple of months, considering the challenge is running until mid-March, and it's going to have, I can't really approximate how many people are going to be submitting certificates or submitting code, but if it's 30 seconds per person, I think it's going to take quite a long time. I think we were waiting a couple of months until we got any of them through previously, so be patient, but they will arrive eventually. And yes, so for now, I'm going to pass it over, and for the break, I think we have the video first. So the video will be first. I didn't give the heads up from the production manager. We'll be doing the video first, and essentially it'll be all the details on what is on the Pi, what's on the Sensat, and what's up in space currently. There are two of them, by the way. Both have a different purpose, and it's very recently different cameras. You'll see why it's different and what cool features you can do with them. So yes, and once that's done, you have about 5 minutes to stretch your legs, get a bit of water, do whatever you need to, and then we'll be right back for the MakeCode Arcade workshop.
Hi everyone, I'm ESA astronaut Samantha Cristoforetti, speaking to you from the European Astronaut Center in Cologne, Germany. And today I'm here to tell you about the European Astropy Challenge. And I have a big surprise. The European Astropy Challenge is an ESA education project run in collaboration with the Raspberry Pi Foundation. students and young people can conduct scientific investigations in space by writing computer programs that will run on the Astro Pi computers. Speaking of the Astro Pis, they were originally launched in 2015 with Team Peak's Principia mission. They were made up of two specially prepared first-generation Raspberry Pi computers with specific sensors. Since then, they've been used to run programs for more than 35,000 young people. Many of my astronaut colleagues and I have all acted as ambassadors for the challenge. Now, after 2 years of secret development, it's time for an upgrade. Here with me today, I am pleased to reveal the brand new Astropy computers for the ISS. These Astropys are packed with amazing features that open a world of opportunity for new experiments. Let's take a look at some of the specs. At the core, we have the Raspberry Pi 4. It has the power of a desktop computer and 8 GB of RAM, all packed into the size of a credit card. Next up, we have the Sense Hat, which houses the basic environmental sensors and an LED display. For the new Astropy hardware, we've added 2 new sensors: a color sensor that will allow you to measure the brightness and color of light in the surrounding area, and a motion sensor that can detect warm objects moving in front of the Astropy. A new 12-megapixel camera allows the Astropy to take images with comparable quality to your mobile phone. We have 3 interchangeable lenses, which will allow you to observe Earth in detail. Astropy IR also has a red filter, which will allow you to measure the health of the Earth's vegetation. Finally, we have a machine learning accelerator. As AI and machine learning become more and more present in our lives, the Astropy team wants to give young people the chance to explore this frontier firsthand. AI experiments require a lot of computing power. So by connecting the new AI accelerator, the Astropys can focus on core experiment tasks, while the accelerator tackles the heavy-duty processing. It can perform up to 4 trillion operations every second. These Astropys are going to be used for the first time in this year's European Astropy Challenge. There are 2 missions that you can apply for. In the beginner level, Mission 0, the goal is to write a computer program that shows a message to the astronauts and tells us a measurement about the environment inside the ISS. This year, you will also have the chance to vote for your favorite choice of name for these 2 new Astropy units. In the more advanced level, Mission Space Lab, you will design an experiment and write a computer program to collect data from the ISS. You can find all the information you need and more on the Astropy website. So, are you up to the challenge? Both missions are open for submissions from today. I can't wait to see your experiments. Good luck!
that was a great video. If you want your code to be run in space by you, you can find more details about it on www.astro-pi.org. Next, we're going to make our own video game using MakeCode Arcade. Now, for those who have never used MakeCode Arcade before, very straightforward, very simple. For those who've actually worked with Microbit, you'll see a lot of similarities between it because it's made by the same people who kind of worked. Well, I say the same people. The software was made by the same people who made the software for the Microbits. Essentially, what you're going to do is you're going to build up a program using blocks. So you'll tell it instructions block by block, and then you'll build a full program, and you can test it in a little emulator on the left-hand side. Once again, because there's no hardware involved, because we'll make sure it's open to everybody to use, all you need is a browser. And to start off, we're going to go... Well, actually, I'll give you an idea what the project is, sorry. The project will be based off of an existing one that's in the arcade library. So the library and Microsoft MakeCode Arcade is very vast, lots of examples. We did have one prepared, but we feel like there's another one on this that might be a bit more fun. For those who have used Chrome, and for those who are a bit more technical or tech savvy, or maybe a bit more curious, you might have noticed whenever you have no internet on Chrome, you have a little dinosaur along a flat plain in the desert. And for those who didn't know, whenever you have no internet and you have that little pop-up, well, I say pop-up, that little window with the dinosaur, you can press the spacebar and the dinosaur will immediately just jump, and then suddenly you're playing a jumping game where you jump over cacti of different sizes and avoiding vultures that come from the top as well. So you have a little game to keep yourself entertained while you have no internet. We'll be making something similar to that. It's called Barrel Jumper in MakeCode Arcade, but we're going to have a couple of own twists on it. The reason we're going through the tutorial system as well on it is to give you an idea how to work with MakeCode, where everything is, and also so you can do it at home in the future. Because there's loads of examples. This, once again, is available all the time. Sadly, this code will not go to space, but you can use it at any point. And they all work the same. So if you want to use a microbit one, there's a little virtual microbit you can use. All very straightforward. Anyway, so to start off, once again, to make sure everything goes back to a very simple point, we're going to go back to Google. And we're going to search, or your favorite search engine, we're going to search MakeCode. And now you have loads of different versions. So you have MakeCode for Microbit, you have MakeCode for... There's boards that people, like I've never even heard of, that use it. We only want the arcade version, so we're going to do MakeCode space arcade. Enter. This search is going to immediately bring up arcade.makecode.com. And we're going to hit that first link. I'll bring you to this page. Now, another thing I didn't mention about MakeCode Arcade that's actually quite cool, they have a certificate system as well, just like the Astro Pi, but in a different way. The certificate system in MakeCode Arcade uses what is a kind of like a progression. So you'll see what are called skill maps right here. I can't hide it, sadly. Right here, you've got these skill maps, and you've got little challenges you can go through. And you can pick up just little bits of code and little bits of knowledge as you go through and build up little games. And once you're finished, you win. Well, you get a certificate with your name on it, and it's just like a little PDF you can download and you can store away for great memories. And so, loads of ones you can work on. I do not want to work on this one, sadly, but to give you an idea, click on it, you get your kind of idea of what the tutorial is going to be about. You can sign in to save your progress, all that. But once you get to the wee trophies, that is your certificate of completion. And these ones are actually quite cool because they're all themed around different kind of topics. So I'm not sure what this one is, but I'm a big fan of the little clownfish in the river. So all of these, very straightforward. They're good beginner style ones. But for this tutorial, we're going to use a single one. We're not going to do a skill map because that would take ages. And we're going to scroll down. So no projects currently, but we're going to scroll down to the tutorials. And one of the ones that we're going to use, if we go to the right-hand side, is Barrel Dodger. Now, it's very basic right now, but we're going to go through a couple of different things, and we're going to spice it up a little bit so we can add our own bit of pizzazz to it. So if you literally find Barrel Dodger, and click on it, it'll immediately ask you how you want to do it, or how do you want to actually make or complete the tutorial. Now, the reason it asks you this is because you have JavaScript that you can work in, and Python. Python is the one that we were using before with the Astro Pi, but JavaScript is a little bit more different and so we're going to avoid coding with that in general. For beginners, we highly recommend the blocks, and the blocks are just far nicer to kind of work with. And if you want to make something, typically it's quicker as well, because you just kind of drag things together and it works. Whereas with JavaScript and such, you can find yourself getting into issues where, you know, if your code is in the wrong place or if something isn't there and you're trying to reference it later, oh, disaster. But the blocks tell you all the time when something's wrong. So I'm also going to make you aware there are loads of sounds in this. Throughout the tutorial, you'll see where you're going to insert sounds. Turn down your system volume, just in case. It is very ear-piercingly loud. So we have learned that on stream, sadly, and it has been quite painful. But as a synopsis, this is going to give us an idea of what the actual workshop is. And we're going to do something similar to this, but we're going to have our own kind of, I'm going to make my little dinosaur, so I am. And what we're going to do is we're going to start by hitting OK. And once again, we're going to have an exact same system. If you use something like MakeCode with the microbit, you'll have your emulator on the left-hand side. So this little button right here, which is the kind of like a little kind of games console, one of the old Game Boys, very similar to that. Once you click it, you get this little box. Now, to start off, we're going to have it on this so we can actually see what we can do with this. Now, you do have a little kind of joypad, and you can interact with this using the arrow keys on your keyboard, so you don't have to like mash around with your, you have to like drag your cursor over and like wrench it onto the thumbstick and start like dragging it different ways to do it, to work with it. Instead, whenever you have your mouse on this screen or on the screen with the tutorial on it, you can use your arrow keys, up, down, left, right, and you can kind of tinker it with them. Or you can use the joypad with them. So I can press Alt4, left, right, up, down, or up, down. You can also use WASD. That's more typical in terms of kind of walkabout games like Minecraft and such. You use WASD. Space for A, and then B is X. So A is space, and then B is X. So a little bit of a weird kind of similarity between that, but it's kind of where your hands are positioned. You can see that WSD is kind of where the top three fingers are, and then your space bar is on thumb, and then you can press X with your index finger going down below the D key. So yeah, now we're going to use primarily space bar because space bar is the usual one to jump over with, but what we'll do is we will go through and mention and see what the tutorial tells us to do. To start, we have to set a tile map. Now, a tile map is basically what you're going to be putting on the bottom of the screen. And essentially, if we go into scenes, set tile map, right here, and you see this little box. Now, the way that this works is you can build and kind of jigsaw piece each part of your code together. So you can see these are little kind of like little pill shaped, and these are like the numbers there are in, well, same thing. Don't pull this out, by the way, this is just for example. I can kind of select different versions and such. So that's a variable, for example. And obviously it doesn't exist, so that's why it's flagging up. But you can put numbers in and everything, and you can kind of take out individual parts. Sorry. Try it again. So you can take out individual parts and kind of chain them together. So let's say I want to change that to, well, you'd have to change it to a sprite, but you can kind of jigsaw piece it all together. Now, at this point as well, just for your reference, I want to delete this code very easily. I press and hold, and I drag to the left-hand side, and the little trash icon appears. And once I hover over it, poof, it's gone. Very, very magic. Very much magic. And we want to go poof. Don't delete this on start, though. We need this on start, because on the start of our code, we want to run certain things. So, starting off again, scene, set tile map, and we're going to drop that in there. And something else you'll notice is that this color of this block is actually the same color as this scene. So, I say this scene, this kind of scene tab. So, if you're ever confused of where blocks come from, so this green one, for example, is in loops on start. So, if you ever have a block that you're confused by or you see in a tutorial and you don't know where it's from, the color is the best way to find out and see what category it's from. There are more, but it's hidden in the tutorial view just to make sure you don't get confused. As there's loads of stuff you can do with this. So, set tile map 2, we're going to click onto the little box and it's going to bring us a little editor. And immediately it's going to look very, very, very different. For those who haven't actually worked on anything to do with tile maps, this is going to be hopefully straightforward enough, but I'm going to explain step by step what you are to do. Now, to begin, we're going to use the pencil tool to draw, and let's say I want to set my tiles to be from, well, what's miscellaneous actually? Ooh, I can make bricks. Oh, I can make a lava actually. Ooh, that's quite cool. Lots of different sprites you can pick from. I'm gonna see which one I find quite cool. Aquatic, I think, is the ones that are used in the tutorial here. But what I'm gonna use is probably forest, actually. Yeah, I'm gonna use the grass from forest. So whenever I'm happy with it, I'm gonna click on it, and what you've seen there is it literally just populates or puts in my tile map whichever one I've clicked, whichever tile map I've clicked on, it has selected it there. So I'm gonna click another one, and you'll see it updates to the different ones. Now, if you're feeling very, 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 very enthusiastic, you want to give this a go, we can always go to my tiles, and we can add a new tile. Now this will be in a tile editor, slightly different, so I could make like I could do a giant high. Obviously this will not be a good tile, but for referential purposes, that is a very higgledy-piggledy high. So I can do that, hit done, and I'll call it my tile call high. When I hit done, you'll see here, now I can place my high. I would not recommend using high because it's not really, a great tile. But if you're feeling very artistically kind of gifted with I'm definitely not. I can't do anything close to this. But if you feel like you want to give it a go, by all means. Now I think it was on dungeon, or was that quite? No, it was forest. I went to the next page. I did. Perfect. I'm gonna select this, and actually, I've just realized we want to change the size because the tutorial mentions as well 10 by 8. So I can do that very easily. So in the bottom left-hand corner, you set your size, which will be kind of the same size as your screen. So it'll scale up or scale down to the size of your screen on the little emulator. We're going to do 10 by 8, so we want 10 tiles by 8 tiles. And now you'll see that it's gotten quite a lot bigger. So before it was 16 by 16, which is quite big. You see the tiles would actually just drag across. You would get 16 in there, so you get like a full row. But instead, make this a little bit smaller. 10 by 8. And then, with that, we want to drag along, maybe along the bottom actually. So I'm going to erase using the little eraser tool, that tile, because I don't want it there. I want it down here. I'm going to drag across, and there is my floor. Oh, that's not what I want to do. And erase that. All done. Perfect. So now that we've done that, we've got kind of a floor, but it's only a texture at this moment in time. In the tile map, we need something called a wall. Now, walls in the physical form are great things to stop you from walking through them, and we don't want our character or sprite. We don't want our character or sprite to fall through the ground. So this little button right here, it's called the wall tool. You click that, you'll see it highlights it, and you can now draw walls, which are basically blocks that you can't fall through or go through. And for your character, we don't want them going through the bottom. So I'm going to highlight over the place I dragged my little kind of floor on. I also would recommend just keeping it on one row, because if you start jumping over hills and such, it might get a bit more complicated. So, perfect. So now that we've done that, we've got our walls. We can see that there's a little bit more purple, a little bit more red tinge to it. We can toggle that by using this little toggle in the corner, just if you don't want to see them, then we can take them off. But just make sure that you have the walls on, or else your character's just going to fall out of the wall, sadly. Now that's good. Quite happy with that. I'm going to call that my level. And you can just name it to anything you find quite nice. No, I don't think it supports space. It does support spaces. So you can do my level, and then spaces or not. Once you're ready, hit done. And now you can see it has set up the tile map to that. So right now, if we go back, we'll see it will have updated, and our screen will be that. And we can always stop it and restart it, or use the restart button, and it'll refresh the emulator. Perfect. Now, I think as well, whenever we're going through these, we can change it to what we want to. So if you want to edit the background or something like that, you can by just going in and seeing my assets. I'm pretty sure it allows you here. You could have like, not using my tile maps, that'd be very bad. And in the gallery, you can put backgrounds, because obviously it's not a wall at that point. So, but for this tutorial, we're not going to put a background on it, just for simplicity. And you can also set a scene in the background, but we can't do that through this current tutorial. Anyway, so we need to find my sprite too. So I'm going to find set my sprite to, so this is a bit different. So if I'm, no, sorry, in blue, set my sprite to, it's kind of the same idea with variables. So we've got a variable called my sprite, and we're going to create a new sprite of kind, and I'm pretty sure our player is the one that we're going to interact with. And so what we'll do is we'll build up a very basic player. I'm going to build a dinosaur really quickly. Although for those who, again, can't draw like myself, but I'll try. There are loads of example ones. Loads, like, just wreak havoc on them. The snakes are quite cute as well, I must admit. Or you'd be a PC. Ooh, I'm actually kind of... I might be won over by the TV. Oh, I could be a little car, actually. These are compelling reasons to not pick a dinosaur. I'm going to pick a car. Lovely. So, this is a car, as noted by the fact that I have just picked it. It's quite a nice wee car. I'm pretty sure, actually, for this, I'm going to have the car, and then what I'll do is I'll give you a minute if you want to try and build something very quickly, and kind of sketch one out. But then we'll start again just to get back to the tutorial. So give you a wee minute just if you want to build up something very quickly using the pixel editor, which just like before with the tile map, you just select a color, you select what tool you need. So if you want to use the eraser, you want to put like, I don't know, a sunroof in your car, or you can like fill bucket for like areas or drawing lines and kind of moving parts or drawing different shapes. So yes, right. Give you a wee moment, let you crack on with that for a minute. Perfect. Okay, so had about a minute there just to kind of tinker around. I'm gonna stick with my car because I like kind of like little red VW Beetle car. So I'm gonna hit done, and then now you can also name it as well. So like give it a name, but I'm gonna miss it for now because it's set to my sprite right here. It's just like a variable. You can rename it. I wouldn't recommend it just for this case. But we want to set our little sprite as a type of player. And so once we've got that, we've got it in our on start. So on start, it'll have our tile map, and I don't think it actually shows up yet. No, it does, but we want to position it. So I'm pretty sure the next part is to position it. Yeah. So we want to place it at a specific point. So with sprites, you have a position. Now, it's kind of weird. You can set individually the X and Y, but I'm pretty sure in your scene, bingo. So in your scene, you can say, I want to place my sprite, which is automatically filled, to a certain column and row, which is how you're measuring your X and Y coordinates in your map. So I'm going to drag this out and drag it to the very bottom. And because my sprite's already selected, because it is my little car, I'm going to set it to, now, this is not the exact same, but you'll notice in the bottom right hand corner, that's in the wrong place. So what you'll notice is at 0, 0, it's in the top left hand corner, which looks a bit weird, but in games, usually your X and Y axis, so your X goes across, and your Y axis goes up. Your kind of Y axis is flipped, so your Y axis goes down. So it goes, so think of this as like your X axis goes 0 for your Y, 1, 2, 3, and because that's his X and Y axis, what we're going to do is instead of using X and Y, we're going to use columns and rows. So columns go across, rows go down. We want to go down. Well, if we remember, it is 8 rows tall. So we want to go to row 7. Ooh. Oh, no, maybe not. Go to row 6. And ooh, there's our car. And we can move the car a bit ahead, just make sure it's not right against the wall. So we'll probably go to column 3. And we'll push it from the left, 3 columns to the right. Perfect. I think Yeah, 3 looks right. So, in a sense, we've just positioned it, and now we're going to add a little bit of functionality to the actual car. Now, as you know, that there are buttons on the little kind of emulator. Very simple to use. Obviously, your space and your X button can be used interchangeably to mash the button. So if you press and mash the space button, it'll smash A in the game. What we want to do is we want to use the controller. So the controller will then allow us to interact with buttons. Specifically, we want to run some code when we press A. So when the button A is pressed, we want to run some form of logic to have our player jump up. So using our sprites, we want to set the MySprite. No, it says MySprite X to 0. This is the correct block. I'll explain why in a moment. But we're gonna pull it down into our little event for whenever A is pressed, and we'll see that this has a couple of options. So MySprite, an X, and the value we want to set X to. Very much like the Python variables we were using before, instead of using an equal sign, it just says set the variable of MySprite, the variable X of MySprite to whatever value we give. Instead, we want to click this little drop down, and all these values will come up. Don't worry about most of them. It's a quite confusing topic to go through and explain each of them. But what we're going to work on is velocity Y. Now, velocity Y is going to be like, setting the variable velocity Y is going to be like applying a force to the sprite, like fling it into the air, because obviously when you press space you want it to jump, so we want to apply a big force to like push it off the ground. But if you remember, the y-axis doesn't go up, it goes down, and the further down it goes, the higher the number. So if you think about it, it goes 0, 1, 2, 3, 4, 5, etc, etc, but we want it to jump up. So in theory we need to do a negative number, because we don't want to increase it, we want to technically decrease it. A little bit odd to kind of think about, but it'll make sense in the game, and for Make Code Arcade specifically. So the example here that they use is -200. I think we get -200 to go. I have done, I think, -100 or I think 50 for our worksheet, or -50. But we can easily test this as well by whenever our Make Code Arcade emulator is ready. We press space now. Okay, it is flung our car into the air. And what we want to do is, whenever it's set, we want to have once it is set, we want to have the car update its velocity, so then its speed is constantly pushing it up. Now, to bring it back down, we need to use gravity, which is very easy to use. We just need to set a constant acceleration for our car, or our sprite, to go down, so to hit the ground, because constantly gravity is pulling down, but we can apply forces to pull things up. So maybe if I want to throw a ball in the air, I apply a force to the ball flies up in the air, and constantly gravity is working against it, so it slows down. And then at a certain point, the force you applied to it initially to throw it up in the air slows down and hits a point where gravity takes over and says, nope, now you're going to apply my force, and because gravity is constant, it comes right back down. So we want to do the same thing with our car. I'm not a physics, I don't have much knowledge in physics, but hopefully that made sense. What we want to do then is, in our on start, we need to apply another force. Very simple to do. We're going to go straight back to logic, or not logic, sprites, and we want to go back to our set MySprite, and we're going to drag it into here after the place sprite, and we're going to have the X, instead of using X, we're going to do AY, so acceleration Y. Difference between acceleration and velocity? It's a good question. I'm going to try and, velocity is kind of applying a speed to something, and your acceleration is a constant thing. So your velocity is applied at a point, and then your acceleration is constant. Don't quote me on that, but it'll make sense in the game, because our acceleration will always pull down our little sprite back. So let's say 500, as the actual example says. So we want to say, my sprite, acceleration Y to 500. And then, if we go back to our emulator, car's back. If I press space, it jumps. It's a little bob. So, as fun as this is, we do need battles though. So, oh yeah, I forgot double jumping was possible. We can fix that as well. That'll be a little add-on. I think I'll do it later. Aha, no, it'll allow us to make sure that, it'll make sure that we have grounded the sprite before we can jump it again. This was another issue I know we faced earlier. So I'm going to move this code over here. And what I'm going to do is I'm going to zoom in slightly so I'm kind of give, I think I can fit all of this in. Perfect. Okay. Now what we're going to do is, actually no, I'll put it here. What we're going to do now is we're going to use something called an if statement. Now, an if statement is just checking a condition. So, for example, a very, very good local example that I can use off the top of my head is if it is raining, which it usually is, bring an umbrella. So if it is not raining, you don't bring an umbrella. And your variable there, or your condition, is whether it is raining or not. So if raining, bring umbrella. It's kind of your action. So your code that you will run, that will run depending on the condition, will be bring umbrella. You'll see an example of this kind of in action in a moment. But what we're going to do before that is we're actually going to build it, and then you'll see it working. So inside logic, you'll have a couple of options. We want to use the top one. And then this if then block right here. And no, actually we want to put it above. You'll see why in a moment. But we want to have this here, and we want to say if and on button press. So when the button is pressed, if this condition is met, then we will allow them to jump. So if in scene, we will pick out is my sprite hitting wall. Now we want to do, instead of left, because we have no walls on the left, we want to have bottom. And we want to say if my sprite is hitting a wall, we want to allow it to jump. So I'm going to put this over here so you can see the entire block. Perfect. So we've just added a very good feature, which is to make sure that, you know, if you give this to a customer or something like that, they can't spam the space bar and they don't fly up in the air and just fling off into, to the ether. Basically, it allows you to only press it once, and until your sprite is actually hitting the ground, can you press it again. So to see that in action, we're going to go back. I'm going to press space, but I'm mashing. As you can see, the A button is flashing. It doesn't do it. No matter how many times I try, it's not going to double jump. It's only going to single jump. So that's worked to charm. That's worked pretty well. You can also do a double jump if you want to. So you can do like if, and you can have a flat. You can have like a variable saying jumped. So jumped is true, or sorry, double jumped is true or something like that. You can say if my sprite is hitting the wall, then allow them to jump. Or you can use the little plus here and say, oh, I want to chain on something called an else. Now we won't want to use an else. We want to use an else if. So we'll create another one, and then we'll remove this else. Don't do this Jira code, by the way. I forgot to mention. But to give an example of how much you can like chain each thing. So you can say, if your variable, if jumping, and say that if it's jumping, you can say jump again. But after the second time, after the time you've double jumped, then you can't jump again. So functionality of that you can add in after the fact. I'm not going to, because I think the example that I had was for adding, well, there's scores and such you can add to this, and music, but we'll focus on the main game first before we start adding that stuff in. Anyway, next up, the actual kind of gameplay is now going to hit with the barrels, but I'm going to make them, what should I make? I can make like little stop signs or something there. Creative vision. So our game doesn't have any, like, well, what they call projectiles in MakeCode Arcade. MakeCode Arcade has a couple of terms for what certain things are. So player is the player that you interact with. Usually you only have one in a level or a scene to actually build up, and then you can use that player to then interact with the world or environment. Our projectiles, though, will be moving from the right-hand side and going to the left-hand side. Now, on camera, it's the opposite direction, from the right-hand side to the left-hand side. And what happens is your car or your sprite will have these projectiles coming in, and you'll have to have it, well, as it's constantly moving in, you'll have your car jump over them, and then you'll land back and then jump over more, and you'll see how much of a score you get. So, simply done. We're going to use the game tab, and we're going to say game update every number of milliseconds. We're going to drag that over here. I'm going to make this a little bit more challenging to myself. I'm going to put it to like 350 was a sweet spot. So I can type in here without using the little drop down, 350. Very simply done. So what this will do is run code every third of a second. And what we'll do is we'll say sprites, and we'll say set projectile, drag this out, not put it into any of our existing code, And I'll move my view over to here so you can see this in better view. We'll say on game update every 350 seconds. We want to set the projectile, and we're going to give this, just like our sprite, a little tile map. So, what does the gallery provide us? Is there a stop sign? If there's a stop sign, this will be amazing. There's no stop sign. Okay, I will very quickly make a stop sign for the game. So I'm gonna have a circle. So I'm gonna drag from this corner to this corner. Oops, sorry, that's the center. I'm gonna drag from the center of this out, and I'm gonna build a circle. Sorta. Kind of works. Yeah, sure. Okay, so I'm gonna build a circle, and then I'm gonna have inside of this with the fill bucket tool, red, and with the rectangle tool, with my color set to white, I'm gonna drag a little bar across. So it's now no entry sign that'll be chasing me. Oh, I need to actually set it. I would also recommend not using a trackpad. That's what points. A mouse is far easier to work with. So there's my little stop sign. Very simply done. So I use the circular tool, draw a ring, and then the draw them you draw from the middle point, and you kind of stretch out your radius and kind of build like a ring from the center point. As you know, as you drag out your mouse, the bigger it gets. I also want to move this. So I want to see, can I select using the select tool? Drag across my little stop sign, and just like this, I'm going to scale it up. I know it's going very quick, but this is a bit more of an advanced kind of tinkering with this tile maps, which I don't think. Ooh, bingo! There we go. Oh no, my stop sign. Oh no. Well, the controls, undo thankfully exists in this, so you can undo your previous steps. I'm going to press and hold. I'm going to drag, and there we go. Okay, so made the top a little bit. It's got a giant forehead, but that's fine. So that's my stop sign. I use a couple of different tools there to kind of build it up. Feel free, though, to use the gallery. I'm going to give you another minute, just kind of put around with that and see how you get on. And then we'll get back. So, see you in a minute. Perfect. So, roughly a minute, I think, if I can count. So I finished my little sprite. I hope you have too. If you haven't, feel free to kind of tinker about. But at the same time, you can always come back and edit this. It's not like it's permanent or anything. So I'm going to hit done, and it's going to save my projectile as a very squashed looking stop sign. And we're going to have it happen. Oh, actually, yeah, okay. I can understand why 300 milliseconds might be a bit more drastic, but we'll see. I'll show you why. Oh, actually, yeah, okay. Because there's acceleration and everything going down, obviously they go down straight to the ground and then they hit the floor. So yeah, so that's not how we want the game to work though. We want it to come from the right hand side, from the right hand side, going left towards our car, so our car can jump over it, or our sprite. So we want to give a velocity, not a 50-50, but we want to have it, so on the next it'll give us an example, minus 100 minus 80. So, let's think of it this way. It'll be moving from the right, so we want our x velocity, so we're going across, we want it to go towards the car, so we do want it to be minus 100. And then, actually, as well, these have little, useful little kind of like drag and drop, or draggable kind of bars, so you can actually, instead of typing, you can use a little picker to kind of pick across a, kind of like I can't remember what you call this bar specifically, but you can pick from the bar instead of you having to type in. So I recommend typing in though, because it's far nicer. And if you go back before the halfway point, it goes to negative numbers. So it's just as easy for doing that. It's just as easy doing negative numbers as it is doing positive numbers. I'm going to do minus 80, so not 5080. Oop. Oh, if I hit minus, it goes straight to 50. Interesting. Perfect. So what that'll do is it'll constantly push the little stop signs. If we go back to our code, we'll see our code right there. It's kind of jumping through. We can fix that, don't worry. And the VY speed, oh, VX, sorry, from a range. Well, we're going to keep it constant for now, just to make it a little bit easier. And the VY speed to 0. That's my fault, I completely forgot. And then, I think when it reloads, yep, goes across. Okay, so it's a lot, but we'll vary the speed in a moment. The next thing is we want to position it. So just like our car, we can position the little projectile. So find the scene, and we want to say, sorry, find the scene tab. We want to pull out the exact same one as we used before for placing our sprite. And instead of placing our sprite, we can place our projectile. So just like a variable, you can use it anywhere. And because it was set up here, we can use it later in our code and say, well, if we look at our car code, we want to say tile map column 3, row 6. So we want the rows to match. That's the main thing. The rows must match. So I'm going to set my rows to 6. And you'll see they'll be on the same line as the car. And then because we want our, well, my stop signs or my projectiles are starting on the left-hand side, but we want it to start from the very right-hand side, we don't necessarily need to use the exact width of the screen. So because this tile map for my little kind of game is 10 tiles across, we could say put something like 11 or 12 because we want it to spawn outside and then kind of flow in naturally. So I'm going to set my tile map column to 12, and then you'll see from the right hand side it'll come over and, oh no, maybe not, 10. Ta-da! There we are. So it's flowing from the right hand side. Suddenly it's going through my car and stopping the car, or my car is very good at running stop, no entry signs. Oh yeah, it's a no entry sign, not a stop sign. I swear I'm a good driver. Anyway, so our no entry sign has been going across, so that's perfect bit. What we need to do next is to have it hit our car. Well, not really hit our car. Once the projectile and the player interact, that's game over, sadly. So your objective is to avoid it. So what we want to do is go next, and we can say, oh, sorry, scores as well. Scores are very, very important because you want to see how far and how well you did. So info, change score by, and we can drag this out, and the score will be displayed at the very end. So once you finish the game, it'll say game over, say score, and I'll also have a high score. So if you want to compete with your friends and see how you do, you can do that. We want to keep the 1 because every time a projectile spawned, you've technically gotten 1 extra point for getting past the projectile. And so on game update so every time you spawn a projectile, you want to increase or increment the score by 1. And then on sprite overlaps, perfect. So our little player is currently overlapping the no entry sign or our projectile, which is not what we want. Oh, you see the score up there as well, actually. So if I maximize this, you'll see top right hand corner, you've got your score incrementing. And whenever the game's over, it just pops up on the screen. It also has a very loud sound. That's where, if you have the sound off, it'll be far nicer instead of it going, I think it's like a duh, 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 duh sound. So it is, which is quite loud. So just be aware. The point, though, is what we want to do is we want to say on sprite overlaps. So this function right here, or this kind of event. So whenever sprite, I'm going to drop it over here. I'm going to move my screen over to it. So on sprite of kind player. So our player sprite, which is the little, for me, it's my little car, or my sprite, is of type player. We want to say if any players overlaps a projectile. Very easy. Very, very easy to do because you're having it. So whenever they interact, you want to run code. And how it's done here is you say sprite of kind player. So any players that are interacted with or that overlap are going to be called sprite. So that's our variable sprite. And other sprite is going to be our projectile at that point. Because if you think about it, you could have 16 projectiles. Let's say you're making a space, like a space shooter game where you're kind of Space Invader, type game. You're going across the bomb as a player, and you shoot a bullet or like a wee missile goes up the screen and it hits an enemy. You got loads of enemies. You don't want all of them to disappear. That's a bit unfair. You don't want every single enemy just poof. You want to have your actual projectile that's hit the specific enemy to disappear. So that's what we're going to use. We're going to have that from other sprite, and we're going to have that interact. Now, this code will run when they overlap, and sadly, whenever they do, it's game over. So I'm going to pull out this from game. You'll have your game update and game over. You can feel free to set it to win. I don't know why you would want to, but set it to lose. And you have other options here for what you want to do with your games. So confetti, maybe not a very good choice for this. Let's do dissolve actually. So game over with dissolve. You'll see actually, oh, there's a tutorial. Poof, and it'll dissolve the game. And there you are. The score is 3, and the high score is 3. So I'm gonna mash. So again, spacebar is A. So I'm gonna. Oh no. Okay. Nailed it. So score is 5. So there you are, and that's a new high score. That's let me know. And for the most part, that is our game pretty much ready. Now, the tutorial does go through a couple of other different things. So if you look at, oh no, it just says nothing. Okay. The other thing that I wanted to mention was the variability and range for your kind of objects coming in outside the screen. 350 milliseconds is quite often, but it just shows how quickly on it shows them quickly spawning in, so you can just quickly test. It recommends a ranged value, especially for the velocity. I would probably say something along the lines of 1 every second. And then what we'll do is we'll have in our math, have a random number picked, and our math value will be between, our random value between minus 100, or maybe minus, if you want to be really evil, you can do it minus 200. That'll be very quick. And minus, there we are. Like minus 80 maybe. I'll do minus 120 to minus 80. Just give a good bit of range. So what I just did was in math, I picked out that block, and as you saw, oh, I don't want to put it there. Oh, that's trying to define random. Good job, Mac. I just dragged it over, and you can see this little line actually, that yellow line between the two red points. It's trying to ask, do you want to join these together, or do you want to like insert this block into there? And when you let go, pops it in. Very simply done. And then from this point, we want to do minus 80 to, we want to put our larger value, or we can do either way. So I'll do minus 120 to minus 80. And then if we wait for this reset, you'll see that it comes at a different speed. Oh, okay, maybe I actually have to play the game. So I can make this a little bit more simpler if I jump. You'll see that's gone a little bit slower, that's a little bit quicker, that's a little bit slower, that's far quicker, that's slower, that's quicker. Ooh. Okay, I'm gonna deliberately die on this next one, so. But that's the game. That's kind of like your variability in terms of your challenge. I'm gonna make this far bigger. I'm gonna make this like 200 just to show how quick and how stupidly fast they can be. So, ooh, okay, I wasn't clicking the button there. Ooh, yeah. And then jumping over them. I haven't got. Ooh, okay. They're quick enough actually. Ooh, right. Okay, I gotta stop playing this because I'm too used to the wee dinosaur one. But yes, so that is your game. Just to give you an idea as well. Here is, in terms of your project, whenever you're finished, you can go on the tutorial, keep going next, hit done, and suddenly, oh, okay, you want to share your project. I'm gonna call mine my car. And we're gonna hit, well, we can hit publish project, but I'm gonna hit no, but I'm gonna name it my car. And then we've got all these options on the left hand side, and one of them is music. So as a little kind of pizzazz to the game, you can add a little bidding, which I'm not going to play on stream, so don't worry. We'll go bidding every time you get a new stop sign, or no entry sign, coming through from the right hand side. And then you can add smaller little things, like you can add info, I think has more as well. So you can say your lives are set to a certain number, and then you can have like a live based system. So whenever you get hit by one, maybe you take a heart, and then you can get 2 more, and then if you hit another 2 projectiles, you lose the game. So give a little bit of variability to the game. But yes, I think for now, other than my car constantly getting hit by the signs or the projectiles, that is us. So in essence, that is our game. The game very basic in a sense, but you can see how the game mechanics can all pull together, especially for how MakeCode Arcade works as well, because it's actually quite a powerful tool. Tinker around with it. There are loads of tutorials, so many tutorials. Have a bit of fun with them. Tinker around. Use the skill maps on the website and have fun with it. But for now, we're going to lead to our outro, because that is sadly us today. And hopefully you've had a little bit of fun making this game. And I'm going to pop this off and I'm ready to go. So, if you'd like to learn more about MakeCode as well, you can go to arcade.makecode.com, the link that we were just there, and then go back to the home screen. We'd like to thank Kevin, Vincent, Stephen, Jack, Ian, and Andrew for doing all behind the scenes work during this jam and making it possible, as well as NITEC for letting us use their space once again. If you love today's event, or you want to see us again, you can take part in our next event by finding us on Twitter at NIRaspberry or NIRaspJam. Thank you. That's everything from me, and we hope to see you soon in person again. Keep well.